Diamond is the hardest natural material. It is also a valuable gemstone, and its industrial use is significant due to its hardness. In diamond, a carbon atom is surrounded by 4 other carbon atoms with covalent bonds between them. If one of the carbon atoms is placed in the center of this tetrahedron, the 4 other atoms are located at its apexes. Diamond has a cubic crystal structure. It is a transparent, colorless, extremely resistant material in its pure form. These are the most valuable specimens, but most natural diamonds are colored. Diamond allows X-rays to pass through, and thus it is easy to differentiate diamonds from other gemstones or glass. In contrast with graphite, it does not conduct electricity. In the presence of oxygen, it burns into carbon dioxide at a temperature of 770 degrees Celsius. Diamond occurs naturally in elemental form. Its polished versions are called brilliants. Diamond can only be polished with diamond dust. It can be found in relatively large amounts mainly in Africa and Brazil. It is formed at a high temperature of about 1,000 degrees Celsius and at pressure of about 5,000 megapascals. The weight of jewel-quality diamonds is measured in carats. 1 carat equals 0.2 grams. The world's largest diamond, weighing 3,106 carats, was found in South Africa. Diamonds are used in jewelry. Its hardness also makes it an excellent grinding, drilling, and glass cutting material. Fullerenes were discovered by Harold Kroto, Robert Curl, and Richard Smalley in 1985. The discoverers of the C60 molecule were awarded the Nobel Prize in Chemistry in 1996. Fullerenes are made up of 5- and 6-member carbon rings. These rings fit on every side. They were named after the architect-philosopher R. Buckminster Fuller, who built a dome reflecting the structure of the C60 fullerene molecule for the 1967 Montreal World Fair. The C60 molecule is one of the best-known fullerenes. It is formed from 20 hexagons and 12 pentagons. Its structure is similar to a football. Every carbon atom is equivalent in the molecule. Due to its structure, it is one of the most stable of the fullerenes. A thin film of C60 is mustard yellow, while a larger mass of it is dark brown. Its fluoration occurs slowly, at a temperature of 70 degrees Celsius through numerous colorful, partly fluorinated intermediate products. There are also fullerenes with smaller and higher atomic numbers, but they are less stable. There are several possible procedures for fullerene production. One possible method is the combustion of hydrocarbons and the extraction of fullerenes from the smoke. Molecules can be produced with an electric arc between graphite electrodes or by using radiofrequency plasma. C60 and C70 fullerenes have also been detected in certain natural minerals. Fullerene is used for making layers of diamond hardness or as a catalyst during oil refining. It can be used in medical science, for instance as an MRI contrast agent. One important property of fullerenes is that they form superconductors with metal ions. The price of C60 has dropped significantly, to 1/100th of the original price, but it is still very expensive, which limits the possibilities for its use. Graphite is a dark gray, opaque material with a metallic shine. It is soft and leaves a mark on paper. Each carbon atom is linked to 3 other carbon atoms by covalent bonds, forming hexagons. These rings form layers. The 4th electrons in the carbon atoms in the layer become shared and form an electron cloud. Due to its delocalized electron system, graphite conducts electricity and heat well. The layers are connected by weak secondary bonds, so they can slip easily. Oxidants form graphitic acid, or graphite oxide, from graphite. Oxygen enters the space between the layers and causes graphite to swell. Graphite occurs in areas prone to strong geological activity, where volcanic and sedimentary rock layers meet. It is used in large quantities in the electrolysis phase of aluminium production, as a carbon anode, as a graphite electrode in electric arc furnaces, and in steel and corundum production. Pencils, crucibles, and filters are also produced from graphite. Colloidal graphite, a permanent solution in oil or fat, is used as a lubricant.